All right, let's go ahead and get started. How are y'all doing today? There's actually quite a few of you here. Normally on days that projects due today, right? Yeah, normally on days of project due, like the class is a little more sparse because everybody stayed up all night doing project stuff and they don't bother to come, but I take it as a good sign. How did it go? Everybody happy? A little bit extra time help? Well, that's good because you're never getting that again. We already used up all our extra time. So, any questions before we get started about stuff? Midterm coming up? Yes, I believe so. It's this Thursday. I already used the today joke last time, so it's too late for that. So I don't know, it's a week from Thursday. The Thursday before spring break, which I think is next week. Yes. Yes. There will be more from me in preparation for the exam. Significant amounts of preparation material before the exam. Yes. Yes. You will. I'll give you something on the scale of like project 2, and I'll say, write this in 10 minutes on the exam. No, it'll be very small things that you'll have to write. I might ask you to write something like if I wanted to make it super easy, because we've only done this 10 times in class, I would say, write me a program that takes an integer and tells me if it's even or odd. Like some small program like that, right? Or that takes a string and tells me how many letters is in the string. Or takes a string and gives you the string backwards. Okay, something like that. Because those are all relatively small programs that you can do in like less than 10 lines of code, I would say would be a good scale. Yes, sir. Yep. Yeah, is it about the file thing? Uh-huh. Yeah. Yeah, or 0 or something like that. So there's, this section and the other solutions split the projects, and I develop the projects, and the other professor does the grading rubrics, and he has things that he thinks are important, and then we kind of negotiate on the grades a little bit. So that's how it works. Yes? How would I return a string backwards? Like, how would I print out a string backwards? I would read a string in using getLine. I would create a for loop, because remember, a string has all the numbers positioned. You can do string.at, and it'll tell you a character. And I would loop from the maximum position of the string down to 0. Does that make sense? Yes? No, there's nothing like set width that is the opposite that puts the spaces after. You can do left and right, which will align format left and right. But most of the time what happens is if you're particularly working with numbers, they're aligned right, but you make the next field over wide enough that there's spaces between them. So, other questions? No? Anything? All right, and so that covers everything that'll be on the midterm. Okay, not really. I forgot to do this. Hi, everybody. Thank you. All right, last time. What did we talk about last time? Do you remember? We had a bunch of epic code is right rounds. Was that fun? How many of y'all think code is right is fun? How many of y'all think it's horrible? I might do a survey monkey because I'm not really sure. I haven't done it before. I'll see how you're doing it. I don't want you to put you on the spot now. But last time we talked about vectors. Vectors. Anybody remember what a vector is? Sir?
It stores like multiple data of the same type.
Yep. It's something called a container. So before we were talking about individual data variables that we had to carry around individually, each with its own name. Now a vector is a container in that it is one thing that has one name that can contain multiple values, right? So it's an idea of a container. The way we get it in C++ is we have pound include vector. We have to use that at the top. This brings up the library that lets us use vectors. And then when we declare a vector, it looks like this. We have vector with a type. These angle brackets are actually there. Those angle brackets actually exist, and I'm kind of abusing the notation because I also use this to surround something that could be replaced with an identifier. So the type, this part that says type, gets replaced, but the angle brackets around it stay, and then the identifier with the angle brackets get replaced. The name, So it looks something like this. If we wanted to keep track of a bunch of names, we would say vector string names, and this meant this vector, which was a container, contained a bunch of strings, and the name of the container was names. All right, everybody good so far? Now, if we want to add names to that, an easy way to do this is to use the pushback method. And the way we use a method is we get the name of the thing, we put a dot, and then what we want to do to it. And pushback, you give it a string. In this case, I gave it a string literal, which is my name, Clay. It could also be a string variable. And what that does is adds it to the bottom, the last place on the vector. Okay. Everybody with me? If the vector is empty, where does it put this name? Pardon? At the 0 spot, which is the bottom, right? It always puts it at the bottom. It's just that if it's empty, the bottom is also the top, so it ends up in the same spot. If you want to know how many things are in there, or in this container, you can use .size. .size tells you, this whole thing evaluates and becomes an integer that tells you how many things are in the vector so that you can keep track of how big they are. And then if you want to access any particular thing in the vector, how do you do that? Okay, you can use .at, but the way we often use this is most often the notation is a square bracket with the number of the position you want to access in there. And then if we want to look at everything inside the vector, what do? We do what? We have a loop. We have a for loop, and we loop over all values. We use a for loop most often because we know how many things are in the vector. How do we know how many things are in the vector? .size. All right, so let's go ahead and look at a couple of other vector things. Wait. Did I not do a vector example in class last time? Did I write some code with it? Oh, is it names.txt? All right, that's much better. Okay, I was confused for a second. Normally I name it vector something, and then I was baffled because it was gone. All right, so let's just take a quick look at this again. This is what we were just talking about. We have a vector of string names. We push 4 names in there, and then we can see we're accessing names either using the square brackets or the .at method. All right, and then if we want to access all of them, we loop over them with a for loop. And again, we use a for loop because we know how big they are. And we know how big they are because we start at 0, we say less than names.size, and then we increment the loop. Why do we start at 0? Because in computer science, for a particular reason which I might never explain to you, we always start at 0. All right? So let me ask you a question. Say we wanted to not print out all the names in here, but search and see if there was a particular name inside there. How would we do that? Sir? Uh-huh. Okay. So we could have inside here, if we say name square bracket I is equal to, what name should we look for? Jane Elk. Then we can output something like okay, we can do something like Jane Elk was in position I, and it will show us where she was. So let's go somewhere and see if we can compile that. All right, it's compiling cleanly, please. Good. And then we can run it. And it tells us Jane Elk was in position 3. So if we want to search, if we want to add things, we use pushback. If we want to search, we use a for loop with an if inside. And that will give us everything that we need. Right? This for loop right here, when you're dealing with vectors, this is your best friend. All right? When you're dealing with vectors and you need to look through a vector, if you need to see what's in the vector, you need to search through a vector, you're going to be using this for loop. And in fact, project 3 will be posted hopefully later today or tonight. I wrote my solution for it. I just have to write up the project. And this loop appears in there about 8 billion times. That might be an order of magnitude or 12 exaggeration, but it's in there quite a lot. All right, everybody good on this? So there's a few other things that we can do with vectors that are kind of some other methods that are actually kind of easy and interesting. One of them is called, well, let's see. Which one shall we do first? So one of the things we can do vector is clear it. Anybody want to guess what clear does? Yes, and what does clear do? Okay, it does not delete a specific thing in the spot. It actually empties everything out of the vector. So now, if we go, if we see out something, and we show how much stuff is in there after we clear it. Anybody want to guess what this prints out? Whoops. Oh, it'd be helpful if I had a semicolon, wouldn't it? So we run it again, cleared names, it is now size 0. So if you ever need to empty a vector for reuse, you can do that. The other thing that we can do is we can test to see if names is empty or not. Now, it being empty means there's nothing in it. Okay. Oh, it didn't work. All right, there we go. So what is this going to print out now? Is it going to be empty? How many of y'all think it'll be empty? How many of y'all think it will not be empty? Anyone? All right. We'll try it. It's obviously going to be empty. Names was empty. Okay, so these are just a few of the methods. If you look online, if we go and look at the C++ vector class, we can see there's a bunch of other stuff we can do. And it actually ends up being pretty useful. If we look at the reference, there's a bunch of other stuff we can do. We can insert, we can delete, you can do all sorts of operations on it. And it's very, very useful and powerful. Okay. We haven't learned about iterators, but you can see how big it is, how much stuff it is. You can resize it and make it different. You can empty it. You can shrink if you have extra spaces to make it smaller. You can do all sorts of stuff. You can push back, which puts stuff in there. You can pop back, which takes the last element out and gives you. Insert, erase, swap, all sorts of stuff. Okay. For the project, you just need what we talked about, which is mostly inserting and searching. We're not going to be deleting or anything. All right. Sir? Insert might do that, actually. We can see. Do you want to test it and see? I haven't actually used insert very much. All right, let's try it really fast. Insert. We need an iterator for this, and we haven't learned about iterators. Yes, there probably is a way to do that, but we don't want to cover the other stuff you need for this yet. Yes? Okay. So the question is, can we sort it? Is that what you want to do? Yes, you can sort it, but we don't know how yet. I can tell you a cheat way to sort it. If you want to cheat, how do we sort it? Actually, I'm not even going to tell you that. I tell you what, I'm going to rewrite my code so that my code, when it outputs stuff on project 3, sorts it, and I'll let you. You don't have to sort it, but you can, if you want to do it, you can come to office hours or ask me or ask the TA, and we'll tell you how to sort it. Okay. Sorting actually is a very important computer science application. And when you get into 052, which is the next class after this, or data structures, you will learn a number of ways to sort things, because some are much better than others. Some are incredibly slow, some are much faster. And then understanding how sorting works helps you understand how to design algorithms that do things quickly. Does that make sense? So it's kind of out of the scope for this. Right? All right, any questions about vectors? Going once, going twice, 3 times. All right, so what we're going to do is, just for fun, because we've been doing other stuff, we're going to do a few small practice problems for the midterm, because it's nice to have sample problems. We'll do this for maybe, we have 4 problems. Most of them are pretty small, so we'll do this about 15 or 20 minutes, then move on to something else. So find a partner. We'll do these in order. The first one should be called formatting using cout. You're welcome. All right, everybody out done with the first one? Cout? No? I'm going with no. All right, we about done with formatting? This one's a hard question, isn't it? How many of y'all are done? How many want one more minute? No one? How many just want me to go ahead and do this so we get the pain over with? All right, you're just saving up the pain for the exam then. So, how do we approach problems? So part of the idea of giving you these problems in class is so that when you find exam problems and you show up on the exam, you have some idea how to approach them. So let me start showing you how I approach these questions using an easy one, and we'll do probably a hard one later or next class. So the first thing that I like to do if I'm giving code like this is I like to number all the lines. I like to write numbers next to every single line of code. And so I'm going to cheat and just do that here. By these numbers, you can see there's some tiny numbers that appeared next to on the screen. And the reason I like to do this is because later, when we have loops and we have other things going on, we need to keep track of which line of code executes in what order, okay? And so if we number them, it's a lot easier to explicitly write down what number step we were on. That way, if we get confused or we, get a little lost, we can look back and go, oh, which line were we on? We were on a particular number. So I've made these tiny numbers appear. Can you all kind of see them? Okay. So where do we start? Where do we start with code like this? Where do we always start every single program? Okay, you can start reading this stuff, pound include, using namespace standard, all that stuff, but where does the execution of the code start? Int main. So when we start tracing code, we're always going to start at int main. Now let me give you a hint about the exam. I will not have code that has errors on it on purpose, okay? Sometimes I'll make a mistake and I might forget one of the header things, but the answer to that question isn't the header is missing, this program doesn't work. Okay? Just assume the code runs, and I almost always test it, meaning 100% of the time, test it ahead of time. So the first thing that happens is we declare a float named value. And what value does what value does value have? Yeah, E out to a large number of decimals, right? 2.71828, 1828, 459045. All right, so we have something stored in memory. Now, my question to you is, can a float actually store this accurately? We don't know if it can store it that accurately or not. I do not expect you on the exam to be able to look at a large number with decimals like that and know if it's stored correctly or not. So you can just assume that if you see something like that, it's going to be stored accurately. Okay? All right, so the next thing is we see out value. Now, this question is actually a very nitpicky, tiny question that helps me separate people in the class who understand general concepts to people who understand details. Okay? That makes sense? So I try to write an exam that you can get, if you have the general concepts, you get a bunch of points, and then if you get details, you get extra. This is very much a detail question. So what does value print out here? Yeah? 2.7182. Why? Because we get 6 digits, right? Anybody, by the way, anybody allergic to nuts in this class? Nut allergies? You are? Okay, I will not hand out peanut M&Ms in class. You sure? All right, I don't want you to. You want some peanut M&Ms? Okay. All right. Well, you want something else? So. All right. So 2.7828, right? 6 digits. That's what we expected to print out. Is that correct? Okay, here's what I'm going to do. I'm going to come out some code so that we don't give away all the other stuff. And we'll compile it and see, because this is really the definitive way of knowing what's going to happen. Oops. 2.71828. It prints out 6 numbers, 6 digits, right? Not including the decimal. You give me that back? Did you get it wrong? Oh, all right. Well, I'll give you a bonus round later. All right. So it prints out 6 numbers. 6 numbers. All right? It's screwy that way. It's just the way it works. Why does it do that? I don't know. All right, so now the next line we add, we make it set width 10. Set width 10. Now what does it print out? Sir? How many spaces in front? 3 spaces in front. So he's saying the number is going to be the same, but there will be 3 spaces in front. So we'll compile, we'll see, and it sure looks like 3 spaces in front. 1, 2, 3. You like peanut M&Ms? Sir? Okay, so here's the deal. I'm not going to expect you on the exam to be able to tell me if it rounds or truncates. Okay, I actually don't always know the rules for that because it ends up mixing in with the representation error. And so I'm not going to expect you to round or truncate. As long as you get the right number of digits, and if you just truncate, that's fine. Okay. All right, everybody with me so far? How many of y'all think this is picky and detailed? Absolutely, I do too. I hate it, but it's a good way of figuring out who's known what. Okay, set precision. Now we add a set precision to this. What does set precision do? Sir? Okay, so your claim is that it will set the number of decimals after the decimal place. Anybody have another interpretation? Competing interpretation, yes? Okay, now the other alternative is it's going to change the number of digits total we show. How many of y'all think it's the number of digits after the decimal? How many of you think it's the number of digits we show total? Oh man, that's going to be a good midterm. Okay, we'll compile again. I recommented that line, right? Okay, I commented again. We'll run it. And look, 1, 2, 3, 4, 5, 6, 7, 8. There are still 8 digits total. So set precision by itself changes the number of digits that are displayed, not the number of digits after the decimal, unless something else has occurred. Okay? So set precision by itself only shows how many digits to share. Yes, ma'am. Because it rounded for some reason. So, listen, I'm just telling you, this floating point math is an area of study all unto itself. I told you I had a semester-long grad class in how to do floating point math. Okay, a semester-long, yes, grad class after an undergraduate degree. All right, so I'm not going to even attempt to explain it here. Just be aware that when you're dealing with floating point numbers like float or double, you will get weird things happening down in the smaller digits, okay? Can you trust a float? No, you cannot trust a float. At least if you have to compare them to each other, you cannot trust them, okay? There is going to be some error, rounding error, representation error in there. Okay, so set precision by itself doesn't show the number of decimals. But now, let's add this. What does fixed do? Sir, oh, you already answered, someone else. Fixed. Yes? Okay, what fixed does is fixed changes how set precision works. Fixed changes it from show me the total of number of digits to display to what you all expect, which is the number of digits after the decimal place. Once you do fixed once, it takes effect forever, just like set precision takes effect forever. So now, if we do this set precision 8 again, what is actually going to be output? 2, and then 8 decimals, 3, 4, 5, 6. So we should get down to around 8.2, maybe 8.3, 8.1, depending on how it feels like rounding. Okay. No, well, 7.5. There you go. We're seeing some sort of representation error here. Okay. I don't expect you to be able to reproduce the representation error. Right, sir? Yes, if we changed all this, if we changed this to a double, which we did not do, it would make all this go away, I'm pretty sure. Right? Because double is way more accurate than float. But I like working with floats in this class because I want to shake your confidence in floating point numbers. I want you to know that the computer can and absolutely will be wrong when you're dealing with floating point numbers. Okay? How do you all happy with me shaking your confidence in things? You got to know when things are going to go wrong, and you got to be able to figure out how to do it. All right, so that's our first one. This is the type of question that would appear on the exam, probably in a longer form, that would be literally designed to test your knowledge of detail. This would probably be like a 10-point question out of 100 to help separate the people who got all the concepts from details. All right, so go on. Let's do the next one, which is what's the next page? It's a CN problem. Okay, so this is a CN problem. I give you one thing I'll notice that it's important to see is when you have when you have at the top a whole bunch of stuff type and it says use this for input, you got to use that for input. Okay, sometimes people will just trace through the program and not look at the input, and then bad things happen to their grades. All right. So the next one, take a look at. Oh, so the question. Let me just revisit one thing really fast. Remember these line numbers, right? The flow of control went 7, 8, 9, 10, 11, 12, 13, 14, and we were done. Right? Pretty easy flow of control. When we start talking about loops, which we'll do some practice problems for loops next class, it'll get a little more complicated. All right. Go ahead. All right, everybody pretty much done with input? This one should have been straightforward because we had another practice sheet about this the other day, right? So let's just rip through this really fast. Who wants to tell me the answer to the first one? And we'll just, sir.
The values I have are 1S19.3.
Oops. Okay, so he claims the values are 1S19.3. Anybody disagree? No? Okay, next one. After 1S19.3 comes, sir. 1S19 point, again? Anybody disagree? Why is that? Because, yep, it finds the biggest one it possibly can of each. And 1 is the biggest integer, S is the biggest character, and 19.3 is the biggest float. Okay? Sir? Oh, okay, so next one. Who wants to run and get me a chicken madness? No, just kidding. Okay. What does the next one print out? Sir, since you raised your hand. 1, 2, 23.7. Everybody got that? Everybody agree? So what is that 2, though? Is it a number? What happens if we add 1 to it? What does it output? No, that puts 3 because it's still a character. But anyway, that was a trick question. But if we add 10 to it, we don't get numbers anymore. We get some sort of strange thing. So it's a character, and it's represented by a magic code. And if we add things, the number gets added to the code. But the code, like, has letters and symbols and other stuff in there. So if we add 1 to it, we'll get 3, but because it's a character 3. If we add 9 to it, we don't get 11. We start getting weird characters there. So I would not expect you to know the code stuff on there. I'm not going to give you. I'm not going to let. I might if I give you 2 a character, add 1, you can say it's 3. I'm not going to give you 9 as a character and say add 5 and expect you to know where in the magic code table you are. Okay. I just want you to be aware that you can have characters that are digits, but they aren't the same as an integer that's a digit. Okay. Character number 2 is different than integer number 2. Very different. Okay. All right. And then the next one. Who wants to do the next one? Sir. Okay, so the next one is 1, 2, 2, 3, then period, then 7. Why? Yes, so it reads the longest integer it can, which is 1, 2, 2, 3. It reads a character, which is the point, and it reads the decimal, which is 7. So that is right. Ooh, a little short. Sorry. I don't like these candies as much. Okay. Next one. Well, let's see. There. So it outputs 1A and then 13.7. Why 13.7? Because that was the original value that was in there. When CN breaks, it quits. It stops doing input, but the values that are in there remain. Okay? The values that are in there remain. Sometimes they get turned to 0, but we're not going to worry about that. Yes? The program would still run. It's just that CN would stop working and you would never get any more input. And any variable that was supposed to be CN2 would just retain whatever it held in there at the time CN broke. It would still keep printing stuff out, absolutely. When CN breaks, the program doesn't stop. Yes, ma'am? Exactly. So if we had just 1A and nothing after that, which was an example I gave in here, it would hang. You wouldn't get any output. But when CN breaks, it keeps going, and because these things already have values, it displays the values that are in there. And then one last one, A12 19.2. Sir? It would be 5Z 13.7. Why is that? Yes, CN breaks immediately, and no more input occurs, and all the original values are retained. Okay, everybody good with that? Sir?
So if that
Yeah, if you put 0, that would be fine too, because we saw that this compiler sometimes for integers, when the CN breaks, put zeros there. But I, yeah, it only does the one that it's currently reading on. So, but I would accept either in an exam situation. So. All right, next one, program to demonstrate unary operators. You should do. I'll do this in like 2 minutes, if that much. All right, who's ready to help me with this one? It's going to output 2 things. Who wants to tell me the first thing that outputs? This one's pretty short, guys. You should be able to do this one in like a minute at worst. Sir, in the back. 80, is that what you saw him? Anything else? Just 80? Oh, and 3. Is that what you said? Okay, so his claim is that A prints out 80 and I prints out 3. Why is that any objections? Is that correct? No? What do you think?
I thought that I minus minus was like kind of interpreted as like in parentheses, but maybe I'm wrong.
Okay. Nope. I minus minus. Well, let's actually test and see if he's right. I've commented the second output, and this one should be. Oops. Sorry. All right, 80 and 3 is what it prints out. 80 and 3 for the first one. Now let's talk about why. When we do precedence, how does the precedence go? Yes? Okay, so what ends up happening is we have to do this unary operator on I first, right? But if it's in front of the I, it means something. Then if it's after the I. If it's front of the I, it says do the decrement, the minus minus first, then use the value. If it's after, as it is in here, it means use this value of I, and then when you're done with it, decrement it. Okay, so what happens is A is 10 times 2 is 10 times 2, 20, times 4, because we haven't decremented it yet. 20 times 4 is? Okay, so that becomes 80, and then, and only then, does I become 3. So it prints out 80 for A, and then 3 for I. Does that make sense to everybody? Yes? Yes. Uh-huh. Yeah. Uh-huh. And you need a space around it. You can't jam variables together. The compiler will probably complain if you had like x minus minus y, it would probably complain that it couldn't tell if the minus minus applied to x or y if there are no spaces. So, all right. Thank you, sir. Here. Yes, question? Oh, if we put parentheses around the I, it might do that first. I'm actually not entirely sure what's going to happen, but I'm always happy to test and see. Still did it after. So, yes? So what I was saying, the question I had is we did something like this, I minus minus A. Does the minus minus apply to the I or the A? Oh, it won't apply to both. There's no way it'll apply to both. That would be crazy. I think it'll probably complain if we do that. Yeah, because it can't tell which the minus minus belongs to. That was the question we had. So. But if you had a space. All right, so in the old days, in the good old days of being a computer science professor, the compiler would do its best to figure out what you meant by putting like plus, 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 minus, minus, and I could create these insane things to give to students on a test that had like 20 pluses in a row. It was wonderful. Those were the good old days of being I mean, I could do stuff like this, right? But now I can't do that anymore because they've changed the compiler to complain that it doesn't make any sense. So literally, in the old days, I could do this. And I could give that to you on an exam, and you would have to tell me what happened and how it figured out. I have no idea what happened. So no, it does weird things, right? Because this is mixed in with multiplication, so you have to do like, you have to do some stuff first. Anyway, I'm just making it up. But in the old days, I could give you absolutely horrible, horrible combinations of these, just designed to break your will and send you crying from the exam room. And now it's a lot more effort on my part to do that. Not that I'm not up to the challenge. All right. Okay, any questions on that? This had a minus minus after it. It would do it first, and the answer would be 60. Yeah. So, like we're about to do here. Something else is about to happen here. Who wants to give me the answer to the second one? Kristen. 40 and 2 is the answer. So, why? Uh-huh. Which gives us times. Uh-huh. Okay. So let's see if that's correct. What was your answer again before I run it? 40 and 2. That is correct. All right. I get nervous throwing over there. I'm going to have to walk to that side of the room to throw. Okay. All right. Everybody got decrement? Increment? And then one last problem, and then we'll talk about something new. All right. This next one, by the way, is an example of what the problems on the exam are more likely to look like. The small examples I give you in class are small examples, and the problems on the exam will contain the knowledge from 2 or 3 of these small ones together. So I think this might have been an exam problem I used a long time ago, and now I've turned it into an example. It's an evil question, by the way. Sure, that's fine. The fractions just have to be right. So. All right, who's ready to tell me the answer to this? Come on, the computer would have been done like a million years ago, computer time. You've answered too many questions. I don't want you to eat too much and get... What? I'm concerned. You got to share it. Yes, you answered one too. Let's find someone. Come on. Who wants to step up? You've answered questions. Go ahead. By the way, this is a really hard one, so we're going to go over this in detail. So what do you think this prints out? Okay, I think I compiled this. Whoops. Eh? Oh, that would help, wouldn't it? That's pretty funny. So, so this is giving us a hint right away. The compiler is telling us that this value is unused, and we'll see this later. I wonder if it actually compiled anyway, though. It did. Okay. So what was the first thing we input? I don't have my sheet in front of me. 2 and 9, and what's your claim it outputs? Oh, 0. Tough one. All right. So the reason I included this in here, this is a horrible question. I don't think I'll have anything quite as bad as this on the exam. But the reason we're doing this on here is because I want to show you how I think about problems like this when I do it. Okay? And by the way, thanks for taking a shot at the hard one there. All right. So here's what I do. Notice that I turn the line numbers on again. And what I do is for each line number, I keep track of what's happening in every variable. So I've split the screen in two here. And what I'm going to do on this side of the screen, on the right side, is I'm going to trace through the code and see what it does. Okay? So what line do we start at? Line 3 doesn't do anything. At line 4, here's what happens. I declare a variable I, and I declare a variable j. And what values do these have initially? What values do they have? We don't know because we didn't initialize them. So I'm just going to put question marks there. Now notice what I'm doing in this window is I'm building a little model of what's going on. I started at line 3, nothing happened. Line 4, I created two variables, and I don't know what they are, so I put what the values are, so I put question marks in them. What happens on line 5? All right, I get two floats named K and L. Okay? So I'm building a little table here that has each variable, and then as I go through each line of code, I'm keeping track of what's happening in each variable. Okay, so the question is, here we are at line 5. What's the value of I? It hasn't changed. We don't know. Has j changed? Has k been a value assigned to anything? Has L been assigned to anything? So we have some variables, but we honestly don't know what's in there. We get to line 6, and we do some input. So, whoops, wrong window there. So at line 6, we do input. We input into I, what? For the first time we're doing this? 2, and then this is 9. And what happens to K? We don't know. L, we don't know. Great. Move on to line 8. This is a screwy line of code. Why is it screwy? Why is it screwy? Because we don't do any assignment here, right? Assignment's important. The computer will calculate things, but it will not remember it unless you assign. So the point of having this line of code in here is to test to see if you are aware that you need assignment to store variables. So as a result of this, what happens to I in this line of code? It goes up by 1 because there's a plus plus I there. It becomes 3. What happens to j? Nothing happens to j. Sir? At the end of this line, it will be 3. So the net effect of line 8 of code here is that I used to be 2, and afterwards it's 3. Now what happens is it becomes 3 and gets added to j, which we knew is 2. And what's 3 plus 2? 3 plus 2 is 7. What's 3 plus 2? Come on. My son can do this. He's 5 today. He'll be 6 tomorrow, but he's 5 today, and he can do it, okay? So this is 5. What happens to that 5? Oh, okay. Well, no wonder you're looking so confused. My son would make that mistake too. Okay. So this was 3. J is 9. We add 3 to 9, and we get 12. Okay? What happens to that 12? Nothing. It just goes away. It evaporates. The computer goes, oh, you made me compute 12? That's fine. I don't care. I'm done. I'm going on to the next step. So does J change? So J is the same. How about K? How about L? Great. What line of code did we do next? 9. All right. So 9. Oh, something happens here. So we compute I plus J, which is 9 plus 3, and we get, and where is that result stored? All right. So J becomes 12. Does I change? It does not. Does K change? Does L change? It does not. Everybody see what I'm doing here? This is how you should organize your work when you're writing it on the exam. It does 2 things. It helps your thinking, and it helps me give you partial credit. Because if I'm able to look at what you were doing, and I see that you made like a small addition mistake, and it spiraled into a huge error at the end, I can go, oh, it was just an addition mistake. If you just write down the number at the end, and it's the wrong number, can I give you partial credit? I could, but I won't. Okay? So, all right, what happens on line 10? J mod I equals 0. Is J mod I equals 0 in this case? Yes, because 3 divides evenly into 12. Does this change the value of I? Does it change the value of J? Does it change the value of K? Does it change the value of L? No. But now we know what line of code we go to next. What's that? 11. We do not jump down to the else because of the if statement. So this first column of numbers here is the flow of the program. It shows what steps occurred. Okay? So now we go to line 11, and stuff happens here. K equals I divided by J. So what is I divided by J? 3 divided by 12 is? What? How can 3 divided by 12 be 0? Because it's a trap. When we do division, the type of division depends on the type of the things that are being divided. What is I? Int. What is J? When you divide 2 ints, you do what kind of division? What is 3 divided by 12 as an integer? 0. 0. That is a trick. And what is L in this case? We don't know. So now we output line 12. I didn't leave myself a lot of space, but sometimes what I'll do is I'll also put a column over here that says output. I'm going to have to make the font a tiny bit smaller, and then I'll be able to do it, I think. Okay? So nothing's changed. It's still 3. It's 12. This is 0, and we don't know what L is. And what we output here is 0. And then the program ends. Okay? What's the next step after 12? Where do we go after 12? We go to 19, and then the program's done. So this is the trace of the code given the first input. All right? Questions? No. This operator, this plus plus and minus minus operator do not need an assignment. The assignment is assumed in there. It's a shorthand for lazy programmers who don't want to have to also type an equal sign. Look, you know, we didn't invent the language, but we got to learn it. So it's like in English, you want the, though, and tough, and through all sound different, but they're all spelled the same. Sorry. You just got to suck it up and go with it. Yes? Uh-huh. Yep. It would print out 0. It would be 0 remainder 9, right? Yes, it would be 1 remainder, whatever the fourth is. So, pardon? It never rounds up. Think about this. When we do integer division, it's like dividing people into groups, right? Like there's normally 44 people enrolled in this class. Say I wanted you to divide into groups of 9. What would happen? There would be 4 groups of 9 and 1 group of 8, right? So think about int division as the number of groups you can form, and then the remainder is the mod is the number of people left over. The other alternative would be we would section those 8 people into small pieces and then divide them among the other groups. That would be messy, all right? So we don't want to do that. Yes, sir. Okay, you can get the same effect if you're careful doing that, yes. No, it's not something you do. And the reason is because other people have to read your code. If you want to do that in your code, you have to put a comment saying, I could have used ceiling here, but instead I'm misusing integer division just to confuse you, right? So, yeah. Sir. This is the output. I tried to add an output column. Sorry. So L is still a question mark, but I tried to add this column over here to show what the output was. All right. Everybody see what's happening here? All right. I'm not going to do it for the other input. You can pretty much figure out what's going on. What happens down here, though? It's floating point division. Why? Because it's divided by a float. Okay. Everybody good with that? All right. So everybody happy? Who's happy? Who's unhappy? Who's glad we're doing practice things before the exam? Me too. All right. All right, so this code will all be uploaded later. I want to move on to something really quickly that will move on. I'm also going to upload the trace that I did, okay? So I want to go back, and I want to start working with vectors of strings a little bit. So if you remember earlier in the semester, we had an example where we had a bunch of different mammals, right? And I've added a few mammals here. And what I want to do is write a program that will load all these mammals in from this file into a vector. So here's my program so far. And we just started. And all I've done so far is to declare a vector of string named mammals. And this vector is going to hold all the mammals. All right. Who wants to talk me through reading the mammals from the file? What's the first thing we have to do? Yes, sir.
So you have to create a variable for the input file.
How about that?
Okay, don't you have to do fstream? I'm confused. I got confused by this.
Okay, so fstream is the name of the library that allows you to stream data from a file. ifstream is for an input file. ofstream is for an output file. Does it work? Okay. Well, let's try it and see. Yeah. Yeah, I don't know. I'm not quite sure what the fstream is doing. It might be a general stream that does one thing or another. It does both, input and output? Okay. Yeah, that's what I was suspecting it did both at once. Like you could probably read and write to it, but it gets a little complicated doing both at once because you have to keep track of where you run the file. But no, ifstream is generally what we use for input files. Okay. We're just going to use the mammals.txt. Great. So we have created the variable to read from a file. We've opened it. Now what do we need to do? Pardon? We have to check and make sure everything happened the way we expected. So we say if not input file. We give some sort of error. And -1 we use as an error code. So this is how we declare an ifstream that will connect our file to our program. We use this to open. We associate that with a particular file. We check that everything worked the way we want, and then we're done. Okay. I'm going to stop and compile briefly because I always like to compile as I go along to make sure I didn't introduce small errors. All right, so now we have to read things from the file into the vector. How do we do that? We're going to have a while, a loop, yeah, and what's this loop going to say? Mm-hmm. Uh-huh. Nope, we need a temporary thing to hold it. It's easier to use. So we have a current fuzzy thing we're working with. All right. Everybody with me so far? How many of y'all think this is going to compile correctly? How many of you think it's not? I have a return. It's just down below the end of the screen there. All right, so let's see if this compiles correctly. It does. Outstanding. Here. Now, who wants to tell me how to print out what we actually got in here? So this should fill, this whole thing we have in there should fill up the vector. Who wants to print out what's in the vector? Go ahead, Kelsey. Mm-hmm. Mm-hmm. You tell me. Outstanding, yeah. All right, so if we run this now, if everything goes well, it should read from the file. Whoops, bad typo there. It should read from the file and output it. There we go. Very nice. Pretty easy. Make sense? All right. Questions so far? Yes, sir. Okay, so the advantage of putting it into a vector is before, when we were processing things from the file, we would read a line, we'd process it, and then we'd go on to the next line. Right? That's what we did for project 2. What we can do now is we can actually remember what were in some of the past lines. Right? So right now, when we read a line, we do stuff with it, we throw it out, and we forget we ever saw it. Right? Now, if we put it into a vector, we have it, and we can go back to it and reuse it later. So, for example, now let's ask the user, let's get rid of this printout loop and do this. We are going to ask the user which animal they want to see, and we'll create something to hold that. So now we can ask the user which animal they want to see, and we can tell them if it was there or not. Okay? How do we figure out if the animal is there or not? Yes? Okay, we're going to use our very favorite loop that we use for everything, which I sadly deleted. And how did we search for things in there earlier? All right. So what we have a loop that says for I equals 0, I less than mammals.size, I plus plus. This is going to give us an I that corresponds to every position in the vector. And then we say if mammals in I, which is the current position we're looking at inside the loop, is the same as the animal the user wanted to see, we output a message saying, here is your fuzzy animal. We'll see if this works. Okay? So let's see if I made any mistakes. We're going to come back to this and go deeper into it next class. I just wanted to get it started. So we run this program, mammals. What animal do you want to see? You want to see a cow? There's a fuzzy cow. Anybody else want to see something? A vole? Oh, look, there's a fuzzy vole in there, too. What other mammal do we want to see? Horse? Anybody like horses? Pony? Anybody want a pony? Ah, there was no pony. You don't get to see a pony. No pony for you. Okay? So the advantage here, do you see now why we're using the vector? It's before we were processing every line, but now we can remember what was in the file, and we can process things that we have in memory, and we can do more stuff. Instead of just getting one shot as we go through, we can access this stuff again and again and again and do things with it, which is cool. All right, have a very good Wednesday. I will see you next class. I'm sorry I forgot to upload the videos from last week. I will be uploading 3 videos today. I converted them, I just didn't get them onto YouTube in time.